Chapter 1 is about the introduction to software engineering. And under this chapter, I'm going to do a small introduction about software development and the process associated to the software engineering principles. And after that, I'll be discussing about software engineering ethics. And finally, I will go through some case studies, which is already in your book. Using these case studies, you can understand what type of softwares are available, so what are the requirements, and so how can we elaborate a software. So let's start. So first thing is, what is a software? So if I ask from someone what is a software, most of you guys simply say it's a computer program. But the software is not just a program. It has a lot of documentations, configuration data, and files are associated with that program. So we cannot run that computer program without these documents and configuration data. So if I say about some documentations, basically we have system documentations and user documentations, like user guides. So the system documentation tells us how the program is built and arranged. Then the user documentation provides the guidance to the end users to operate the system. Suppose we have developed a website for a particular company, and we have handed over the deployment guide to their the IT department to deploy it. So in order to deploy, the system administrators should know how to deploy the website and what are the data should be inserted before the first use of the website. So those are the configuration data and the deployment details. So all these information should be documented. Otherwise, the interested people doesn't know what it is and how to do the deployment. Also, after deploying the software to their environment, the end users should know how to access that the web application, the web URL, and how to what are their credentials like username and password, and what are the features that we are giving from the website to them, and so what are the different web pages available for them based on their user levels. So basically we can say this is a software and the documentations related to that. So we can categorize these software products in different ways. In most simplest way, we can categorize into two, like generic products and customized products. So generic products are created by a software developing company, and they also own that product. So these type of the products are available in the open market, and any user can pay for it and buy this product. The features of this product are decided by the software development company, who is the owning company of that product. Also, they are the person who decide the changes and the constraints of this product. So we can say like Microsoft SQL, the Microsoft Office package as the examples of generic product. Hope you have used the package, Microsoft Office package. So you can understand that we don't have to do any configurations on that. What we have to do is just we have to just install it and use it. So these type of products are called as generic products. So customized products are developed for a specific customer, and that customer is the person who owns that product, not the software development company like the generic products. And so all the decisions and the features are decided by that company, the customer, and the constraints and the changes related to the features are decided by that customer. As an example, I can say about a specific website for a company and the learning portal in your university, also a customized product that is specially developed for your university, and you are using it. Not the general public doesn't have access to that product. So it is about software and its types. Hope you can understand that. If you are not clear about that, you can ask any questions. So what is software engineering? So it is about engineering discipline and the all aspects of software production. In this definition, you can see I have highlighted two keywords like engineering discipline and all aspects of software production. So what is a engineering discipline? So engineering discipline using theories and methods for a specific problem. To use these theories and methods to solve these problems. But to solve that problem, we have to consider the organizational and financial constraints. For an example, clients need to have a report in his software. So implement that report, we can use different types of ways, like using SSRS server or third-party tools like iTex Sharp, iTex 7, like there are so many third-party tools. So if we have the multiple ways of developing it, we have to consider the cost of implementation and and we have to select the most cost effective method based on the client preferences, because we have to consider more about the client preferences as well, because even the cost is very low. Some clients doesn't like to use third-party controls because with the time sometimes they are stopping the support and giving new features. So likewise the customers have to select the correct solution, and what we have to do is we have to keep in mind about the constraints, and we have to give the different solutions to them. And then what are the aspects of the software production? So it includes the methodologies of software development, project management, development tools, methods and theories. So all of these are the aspects of a software production. We have to consider all of these aspects when we think about software development and software engineering. So we'll move to next slide. It's about the difference between software engineering and computer science. Basically, the computer science focus on the theories and fundamentals. But the software engineering is focused on the practical problems when developing the software. Normally, we use some theories and fundamentals in computer science to solve the problem when developing software. But the developer use informal ways to solve the problems as well. So we can't say we always use the theories and fundamentals which is included in the software, the computer science to solve the problems in software, but those theories and fundamentals can be used. Also, there are some theories and fundamentals that we learned during our learning period are never used while using the developing the software specific products that depends on the software they develop and their domain. Software engineering versus system engineering. So system engineering is all about all aspects of system development, and it deals with all the hardware, software and process engineering related things. But software engineering is a part of system engineering. So in this picture, you can see that there are different sections like society, the organization, business processes, application systems, the communication and data, the operating system, and the equipment. So when we talk about software engineering, it's concerned about the operating system, the data passing around the software and the application systems, and the business process, especially business processes and the requirements, and then about the organization constraints and all. But the system engineering, apart from all these aspects in the software engineering, we consider about the equipments as well, like what are the servers that we are going to deploy our system, and the network related things. And so all these aspects need to be considered when we're talking about system engineering. So we move to the next slide. It's about software process. So software process is a set of activities and results that produce a software product. So if we develop a software product, there are different types of activities we have to pass until we complete the software product. So we start from the software specification, and we have to go up to software evolution. So there are some activities I have listed down here. So software specification, software development, software validation, and software evolution. So I'll go through one by one. So the software specification is defining the software and its limitations. And both customers and developers agree with functional and non-functional requirements. So I will tell you about functional and non-functional requirements in the later of this today's session. So after identifying what is the software and its requirements, we start the software development phase. And in this phase, we do design of the software using different notations, and then we start the development. While doing development, we have to, as the developers, they have to do the unit testing and integration testing. So unit testing is developing a small part of this software, and the integration testing is the testing. They integrate two small units and test that integration is working correctly according to the software specification. So I will show you some unit tests, how to write unit tests, and some criteria that we are looking in the unit test in this chapter. So after completion of the development, the software validation phase is started. In this activity, the quality assurance team have to come into the picture, and they check whether the software is matched with the customer requirement. So if there are any mismatches, they send the information to the development team, and the development team again fix those issues and send it to the quality assurance team. So after the software validation is completed, the software is installed in the customer's environment, and the software evolution is happen after that. The software evolution is the change in the software that we have already developed. So why we need to change that software? Because the client's requirements are changing day by day, and their business processes should be aligned with the law in the country. And if some acts are getting changed, and they have to change their software according to that. Likewise, we have to modify the system. So for an example, so I have developed a website for a Canadian university, and after some time the Canadian government has added a new act to access that website for the disabled people, like the deaf and blind people. So they should also be able to access that website. So we have to do the changes according to that act, and we have to support the software for such people to access that website. So it's one example of a software change. So those are the main activities that are linked with the software development. Move to the next slide. It is about software process models. So there are different software models. So actually it's a simplified representation of software process which is presented from a specific perspective. So there are few process models I have listed here, and workflow model, data flow activity model, role or action model are some of the process models that have identified. So in workflow model, it's a flow of sequential human activities that happens one after the other. For an example, we start from requirement gathering and then move to requirement analysis, and then we can move to the design, then development, the validation likewise. But in data flow model, it represents the software process as a set of data transforming activities, and also it can have computer activities. So last model one is role or action model. So it mainly focuses on the roles of the people who are in development process. So also it focuses on the activities those people are responsible for. So these are the types of some software process models. So then we are going to talk about different type of costs associated with software engineering. So we have already identified the activities of software development and its life cycle, and each of these activity has a separate cost, like cost for specification, cost for designing, and the cost for the development of the software, and cost for testing and validation likewise. So you can see in the picture, so there are different types of software models, and you can see that in the waterfall model, different percentage of budget from the project is allocated to different types of costs. Like the larger portion of the cost is allocated for integration and testing. So likewise, so different software development processes have different levels of cost incurred in different activities in the life cycle. But these percentages are not hard and fast rules. That may depend on the business and the interest of the customer likewise. For an example, some systems are very critical systems. So like the aircraft systems, for such systems we have to spend more on integration and testing. The systems like the information gathering systems, some clients don't spend much on the integration and testing than the life critical systems. So what we need to keep in mind is the different percentages are allocated for each activity. It's not equal percentages of the cost. So next one is software engineering methods. So it's a methodology having planned the ways to develop software. This describes the system models to be developed. It helps to develop high quality software with low cost. And there are some components included in software engineering. So like software model description, notations, rules, design advice, process guidance, likewise. So we will discuss these things deeper in the later of this course. So I'm not going to introduce one by one, and I will move to the next slide. It's about the attributes of good software. So here I have listed some attributes of good software. So after maintaining after deploying the software, so user requirement and business processes are changes. So I have told you an example earlier. So we have to modify the software to cater these requirements. So if we have a lot of effort and cost to change the software, so it's not that good. So when we design the software, we have to think about the easy maintainability about the software, and then the dependability. The dependable software should not create any damage if the system breaks down. And also software should work efficiently with high responsiveness and less processing time, like the quick responses and the processing time. For an example, we can take a aircraft system. Normally in the aircraft systems, they have defined the response time. So the response should be received to the user within seconds, like milliseconds or seconds. They have defined it. So as the developer team, we have to consider that, and we have to achieve that the response time. So likewise, that's the good software should be efficient and the less processing time should be there. So the last one is usability. That means it should the software should be easy to use and understand by the end users. Suppose if you go to a website to buy some products in a e-commerce application, so if we can't find how to order the product easily, the users doesn't like to order from that website, and they go for any other commercial platforms like e-commerce, any other websites. So when we design the software, we should think about the usability of the software. So those are some attributes of a good software. So other than that, it should the software should be more secure. So we have to think about the security as well. So there are some challenges we faced in software engineering. So the heterogeneity challenge I'll start with a small example. So when we develop a program, it should be able to run in many platforms. So I can tell you the practical exam. So I found a customer. He came to us and he said they wanted to develop a questionnaire designer and a weaver. So they want to deploy it in different cloud platforms like Azure and AWS. So the way of deploying and the features of Azure and the Amazon Web Services are different. And we have to find a solution to support for both of these platforms. So when we design system, we have to think about the feasible design for both the cloud platforms. So these type of challenges are called as heterogeneity challenge. So delivery challenge is the challenge on how shorten we spend the activities without sacrificing the quality. So basically how fast we can give the software to the customer without the sacrificing its quality. The next one is trust challenge. So users should be able to trust the software. For example, in an e-commerce website, to purchase the goods, we provide our credit card details to the website. So we have the trust of this information will not be exposed to any third-party users and softwares. So we have to think about security under the trust challenge as well. So these are some of the software engineering challenges, and then I will move to a very important topic called ethics and responsibility. So it plays a major role in software engineering. So as developers and the quality assurance team, we should apply our technical skills to develop the system. But other than that, we have a bigger responsibility on other aspects like confidentiality, competency, intellectual property rights likewise. So the confidentiality, we have to protect the privacy of our employers and the clients. So normally we don't expose the business and the client names to the third party companies and the external people. It's a special thing that we keep in mind, that we have to keep in mind when we work in the industry, because some clients, their businesses and the business processes are very confidential, and they don't want to expose this information to the external parties. And the next one is competency. So we must have the skill set that the client need, and we must not lie about our skill set. It's one of the most important thing that we have to keep in mind, because some companies show and tell that their employees have the skill sets that they don't have, and they are trying to get the business from the customers. But after that, the softwares that developed are not in that quality, and sometimes we may have to face some delivery issues like not able to targeting the delivery dates and not able to develop the expected features. So the competence is one of the most important professional responsibility when we talk about the ethics and responsibilities. The next one is intellectual property rights. So we should be aware of the government laws, like I said earlier, and like the patent rights and copyrights. And also we should not misuse the others' computers using our skills. So as developers and testers, we have the client server information and we have the access to it. So we should not misuse those servers for our own purposes, like downloading large files, spreading viruses, and play games. So we don't, we should not use these resources, and it should be a very we should use those resources and access those resources in a very responsible manner. So we'll move to the next one. So there are some professional organizational bodies who are preparing these type of ethics. For an example, the Association for Computer Machinery, the ACM, and the IEEE, the Institute of Electrical and Electronic Engineers, and the BCS, British Computer Society, are some of the institutions that are preparing the code of ethics. So in order to get the membership of those organizations, we have to accept this code of ethics. Otherwise, they don't give us the membership, and we have to maintain it. And sometimes they check whether we are following the code of ethics, and if we are not following those, the membership will be cancelled. Here is a sample code of ethics that has been created with the joining of Association for Computer Machinery and Institution of Electrical and Electronic Engineering. So here you can see there are different types of ethics that have been listed. So in public, they have mentioned software engineers shall act consistent with public interest. Yes, it should be done. And the client and the employer. So software engineers shall act in a manner that is in the best interest of their client and employer, consist with the public interest. So we have to, as software engineers, we have to know the interest of the client and the employer, and also we have to consider about the public interest as well. So likewise, they have different types of they have imposed different types of ethics. These are not rules, but we have to follow those, otherwise their membership will be cancelled. Then we will move to case studies. Those are already in your the study guide, and I will go through the requirements of these case studies, and while going deeper into the topics, we can use these case studies to analyze these things, and we have to model these softwares. So there are 3 case studies here. One of this is a personal insulin pump, and another one is the management information system, and the last one is a wilderness weather station. It's a collecting data from some device and analyzing features are also there. So I will move to the insulin pump control system. So it collects data from the blood sugar sensor, and it calculates the amount of insulin required to be injected. This is a very safety critical system, because if we calculate the dose of insulin incorrectly, the sugar level of the blood will be reduced, and some brain malfunctioning and coma status can be happen. The last step is a death. So we have to be very careful when we design the safety critical system like this. And after calculating the dose, we have to send the signals to the micro pump to deliver the correct dose of the insulin. So here's the high-level hardware architecture of that system. So in this machine, we have to have a power supply, and we have to reserve the insulin in somewhere in this system. So we have to have a clock, because this the monitoring happens within a specific time period. So we have to have a clock, and it triggers the controller, and after triggering that controller, it gets the information from the sensor, and so it calculates the blood sugar level. So if it is so high or low, it's alarming to the end user, and also it displays the sugar level in the machine. And also after that, we have to calculate the dose of the insulin that we need to pump, and it also should be displayed in the machine, and then the controller sends the signal to the pump to inject the insulin. It gets the insulin from the reservoir and inject the insulin, the correct dose, to the patient. That is the high-level architecture, and this is the hardware architecture. So this is the activity model of the insulin pump. As I mentioned earlier, it's get the blood sensors and analyze the sensor reading, and then compute the insulin dose, and we keep the log of that dose and the readings. Also, after the computation, the insulin pump will be happen. So these are the high-level requirements of this insulin pump system. The system shall be available to deliver insulin when required. Yes, it's a embedded system, so we have to keep an eye on the blood sugar level. The system shall perform reliably and deliver the correct amount of insulin to counteract the current level of blood sugar. This is a very critical thing because, as I told you earlier, if we calculate the amount incorrectly, or if we pump the dose incorrectly, it will happen a lot of bad things. So we have to very careful on this requirement. And the next requirement is the system must be designed and implemented to ensure that the system always meets this requirement. So these requirements should be there on the system. So if one of the functionality is not working correctly, it will happen lot of dangerous things. So that's why we call it as a very critical system. So then we will move to the next case study. It's about a patient information system for mental health care. So a patient information system is supposed support mental health care. This is a medical information system that maintains information about patients suffering from mental health problems and the treatments that they have received. Because these type of the people, the patients who have the mental disorders. Hello?
Yes, miss.
Is someone asking me questions? So, no, right? So this type of patients who have the mental disorders doesn't know about their treatments and the medicines that they are taken. And if they go to a doctor, the doctor should have the information regarding those people, the patients. So it is important to keep this information in somewhere. So that's why this system is designed. Also these patients do not require dedicated hospital treatments, and they go to the specialist clinics regularly, and they can go to different types of specialists, like they can meet multiple specialists for different types of the disorders and some other illnesses as well. So in that case, all these doctors have to have good knowledge about their problems and the treatments that they are taking. Otherwise, the same drug will be given to the patient twice, or the doctors may have missed the important information. Likewise, so to make it easier, this system will be created, and also it needs to keep the information in a centralized location, in a centralized database. And the system can be run on a PC in doctor's machine or a hospital, in a machine in a hospital or a clinic, and this can be accessed by authorized people. So for some clinics does not have the secure network access, and the network is not reliable. In that case, they use patient information database downloaded and use local copies of patient records when they are disconnected. These are the requirements and the high level need of the system. And also the staff, the medical staff needs to have some reports regarding the patients. And these different type of user levels can access the patient information. So here's the basic structure of the system. We have the centralized database, and the system is hosted in a server or in a local computer. And from the clinics, we can access this database and get the information from the database, or keep the local copy in their clinic. But we have to update the database when they are online. Otherwise, this information and is not sharing with the other medical practitioners. It's very important thing in this system. We should facilitate to sync the data with the live system. So these are the key features: the individual care management. So the doctors create records of patients, edit their information, and keep the summaries with them to attend the immediate situations. And the patient monitoring also should be there, and the administrative reporting, as I said earlier. So they have to have some reports regarding the patients and the number of patients treated at each clinic, and the number of patients who have entered and left the care system, like who have stopped their treatment and cured successfully, and who have left without taking continuous medicine. Likewise, and these are some concerns about the system. As I said earlier, there are different levels of information accessing people. So we have to think about the privacy of the patient, because these type of information should be confidential and should never be exposed to any external parties. So the privacy is a must, and the safety. So some patients who have mental disorders trying to commit suicide and danger to other people, and some are trying to hurt himself, and they wanted to see the blood. Likewise, there are different types of mental disorders. So the system should warn the medical staff about that warnings and the potential suicidal and dangerous patients. So that feature should be there, and it's really a very important thing in the system. Also, the system must be available when needed. That's why we should have the facility to keep a local copy of that system, and otherwise the safety may be compromised, and so many dangerous things can be happened. This is the last case study. It's about collecting data from a wilderness weather station. So a government of a country which has a large area of wilderness have decided to deploy several weather stations in remote areas and get the weather information and environment parameters from these areas. So we have set different instruments and get the measure of different parameters like temperature, humidity, pressure, the wind speed, wind direction, the rainfall amount, the sunshine likewise. So the weather station includes different instruments, and we get the details from these instruments, and it sends those information to the main system, and it analyzes the data and predict the weather in that area. So this is the high level architecture. We have the weather station, and we have data management and archiving. From the weather station, we send the information to this system. It's analyzing data and archiving the received data. And we have a station maintenance system also, because these stations and the devices should be maintained, and we should check whether the readings are correct. Otherwise, false analysis reports will be generated. So as I said, this is responsible for collecting weather data, and it collects from data from different weather stations, and analysis is done in this data management and archiving system. Then the station maintenance system is also there. So we have to communicate the satellites and the other the devices that we have fixed in different areas. So we have to maintain those things using this system. So other than that functionality, we provide some additional functionality using this system. So monitor the instruments, power and communication hardware, and report faults to the management system. Yes, it should be done, because if the power supply is not up to the expectation level, the readings are not received as, and the network, if there are any network issues, also we will miss some important readings, and so these should be considered. And also manage this system power, ensuring that batteries are charged whenever the environment conditions, but also the generators are shut down in potentially damaging weather conditions such as high wind. Yes, that should be done, because in a different weather conditions, these instruments should be safe. Otherwise, it will be sending incorrect readings, or it doesn't send us the readings. So the support dynamic reconfiguration, where parts of the software are placed with new versions, and where backup instruments are switched into the system in the event of system failure. Yes, when we design software, we have to think about backup. Suppose we have a single copy and a single we have deployed our system in a single server, and the system the server failure becomes inaccessibility of our system. So users can't do their work without accessing that system. So in order to cater like this type of failures, we have to back up a system for immediate restore, or we should think about different deployments in different servers, or deployed in Azure. It's very we have high availability, and we have the trust that they are maintaining their systems likewise. So we have to keep in mind about the backups when we design a system.